everybody, welcome back. We've learned about work and we've learned about how machines make work easier. Now we're going to learn about 6 simple machines. A simple machine is a machine that does work with only one movement. There are 6 types of simple machines. Types of simple machines are pulley, wedge, screw, lever, inclined plane, and wheel and axle. The first type of simple machine we're going to talk about is a lever. There are 3 classes of lever: first class, second class, and third class. An example of a first class lever is where the fulcrum is in the middle. As you can see in this picture, the screwdriver represents the fulcrum, and the input force goes out on the end of the ruler opposite of the book, and the output force is where the book is. This book weighs about 10 newtons, and with the screwdriver in the middle as the fulcrum, the lever doesn't have enough to lift it, it just bends. Now as I move the fulcrum closer to the book, the input arm becomes longer, thus making it more a mechanical advantage and it lifts a little easier. And it will be even easier still if I move the fulcrum closer. To demonstrate a second class lever, I'm going to create a load with this piece of clay, and I'm going to use a ruler that is taped to a table. Next, I use a spring scale to measure the weight of this clay ball, and as you can see, it has a weight of about 1.4 newtons. Now we know this is a second class lever because the fulcrum is in the end where the tape is, and the input end is on the other one, actually where the hole is. That's where I'm going to be hooking up the spring scale. And then the weight of the clay ball makes the output force. So now I use the spring scale to lift on the end of the ruler, and I get a reading of about 1 newton of force. And I will gain mechanical advantage if I move the load closer to the fulcrum. This time I get a reading of about 0.8 newtons. And one more time I'll move the load closer to the fulcrum. I connect the spring scale, and this time I get a reading of about 0.4 newtons. An example of a third class lever is this rat trap where the fulcrum is the center part and the input force comes from the springs that are attached, and the output force is way out on the end of the trap. The third class lever is to gain speed as the input force is carried over a longer distance. That was so much fun. Let's watch that again in slow motion. The next simple machine is an inclined plane. First, I start by measuring the weight of the weight, which, as you can see, is 4.4 newtons. To demonstrate how this inclined plane works, first I show you that I would have to lift the weight straight up 0.17 meters to find the work done before I use the machine. Next, I measure the length of my inclined plane, which happens to be 0.51 meters. The mechanical advantage in this situation is about 3. 0.51 divided by 0.17, but actually because of friction I have to lift a little bit over 2 newtons. By making an inclined plane shorter or making the ramp longer, you have a lower slope, making the mechanical advantage greater. Now the amount of force that I need is under 1 newton. Our next simple machine is a wedge. A wedge is an inclined plane that moves like on these scissors. The wedge causes the output force to go in a different direction than the input force. You go down with the scissors, the wedge goes out. I'm using the scissors to show the next demonstration. Use the wedge to cut paper. You can see that I have an inclined plane with the paper that's there with the red line. And I'm going to take that inclined plane and I'm going to wrap it around a cylinder. And when I wrap a inclined plane around a cylinder, what I get in the end is something called a screw, which is our next simple machine. So as we just said, a screw is an inclined plane wrapped around a cylinder. I use this screw to turn into this board, and as each thread goes in, that inclined plane pulls harder against the wood that's there, holding it in tighter in place, or holding two parts together really tight. Which brings us to our next simple machine, a wheel and axle. A screwdriver is an example of a wheel and axle, where the handle part is the wheel because it's bigger around, and then we have the axle, the middle part, that turns with the wheel to give us our mechanical advantage. Next we have pulleys and pulley systems. This is an example of a pulley that only changes the direction of the force. As you can see, I pull down with a force of 4.5 newtons, and the weight lifts up 4.5 newtons. Another type of pulley is a movable pulley in which the rope is fixed but the pulley is with the weight, and when you lift on the spring scale, the weight will come up half as much, just a little over 2 this time. A movable pulley has a higher mechanical advantage because it changes the distance the force acts. A pulley system is a combination of fixed and movable pulleys, and you gain mechanical advantage for every rope that pulls up. As you can see with this system of pulleys, it changes the mechanical advantage, causing me only have to lift with 1.5 newtons of force. Just for fun, I put together one more pulley system that has 3 pulleys on the fixed pulley and 3 pulleys on the movable pulley. And as you can see, it doesn't take that much force here. In fact, the force is less than 1 newton. Well, folks, now it's time for that segment of the show where we rewind and talk about all of the things we've learned about simple machines. A simple machine is a machine that does work with one movement. There are 6 simple machines: lever, inclined plane, wedge, screw, wheel and axle, and pulley. First class lever has the fulcrum between the input and output force. Second class lever has the output force between the input and the fulcrum. On a third class, input's in the middle. Inclined planes are sloped to help with lifting. A wedge is an inclined plane that can move. And a screw is an inclined plane wrapped around a cylinder. An axle has an axle and a wheel that turn together. A pulley is a grooved wheel with a rope or chain around it used for lifting. Well, that's all I have for you right now. Thanks for watching, and see you soon.